No? Testing. Oh, there we go. All right. Sorry, everyone. So the next session's on OpenTelemetry. I want to provide an overview of what the project is and talk about some of the backwards compatibility for those of you coming from OpenTracing or OpenCensus. First, a quick introduction, maybe. Let's see. All right, cool. My name is Steve Flanders. I'm head of product and experience at a stealth startup called Omnition. We are in the observability space based out of California in the United States. If you're interested in learning more about observability or what I do, I've provided some links here at the bottom. All right, so some background. I'm going to start by talking about OpenTracing and OpenCensus. You may have heard of OpenTracing because it's a CNCF project. You may have heard of OpenCensus because it's very popular in Google Cloud Platform, GCP, or in Microsoft Azure. Both of them use OpenCensus today. So let's provide some background here. When we talk about observability, or you might hear the word telemetry, there's really three different verticals. You may have heard about the three pillars of observability, which is basically tracing, metrics, and logs. But there's also a few different layers for each of those verticals. You have the instrumentation APIs, how you actually get tracing data, metrics, and logs. You have the implementation detail of how you're going to pull that data out and send it to the back end of your choice. You have the data infrastructure to support that and actually be able to query over it. And then, of course, the various different formats. As it turns out, this is a pretty complex problem because on top of the verticals and layers, there's also a polyglot of different languages that you could have written in, and you have to solve that problem for each of those languages. So there were two projects that existed. One was called OpenTracing, the other was called OpenCensus. They were similar, they were not the same. So OpenTracing came out first. I think it came out in about 2016. Basically, it solved one vertical, tracing. All it did was tracing. It had one layer, an API, just the API for the instrumentation aspect. It was loosely coupled, supported a ton of different languages, and was broadly adopted. It's already part of CNCF, so that shows that it was widely used. On the flip side of the house, you have OpenCensus. This came out in early 2018. It actually attacked both traces and metrics. So it solved two different verticals. Not only that, but it addressed both the API as well as the implementation. So it was the first solution to provide an end-to-end solution to this problem space. It was more tightly coupled in terms of the frameworks and instrumentations and libraries that it supported. It did support a broad set of languages, 5 of them in beta, and it was broadly adopted. Now, just looking at this slide, you can see that there's some amount of overlap. And these each had pros and cons. Let's talk about the cons. OpenTracing only addressed tracing, but I'm assuming most people use metrics and logs today, so you probably want more than just tracing. On the flip side of the house, OpenCensus was tightly coupled, while vendors specifically would prefer a more loosely coupling aspect so they can differentiate on the different analytics that they're providing. So these were kind of some problem areas in each of them. They, of course, each had strengths as well. Now, from an adoption perspective, both had very healthy ecosystems. They were very active on GitHub. There were a lot of contributions, and they were backed by a wide range of contributors. And the OpenCensus side, Omnition was one of the companies with Google and Microsoft to basically form OpenCensus and build the client libraries as well as the OpenCensus service. The service was made up of an agent and a collector. That was basically part of the implementation side of the house that was missing from OpenTracing. And other providers and users were also getting actively involved in OpenCensus as well. Sorry, 1 second. It sometimes cuts out. It'll come back. There we go. So both projects were well adopted. Great. Well, kind of. The problem is that there was no clear winner. Both were doing very well. And that's great, except for the fact that as a user, you might be asking yourself, well, do I use OpenTracing, or do I use OpenCensus, or do I use both? I'm confused as to what to do. This actually is very well represented in a Hadoop ticket. I have a link in the slides that you can go take a look at, where someone basically asked, do we use OpenTracing or do we use OpenCensus? And it's been open for a few years, and there's no answer. Not good, right? Like, people don't want to have confusion. They want a single solution. Ideally, they take one dependency, and it just works. And at the end of the day, if we have an open standard, if we have an open API, if we have an open implementation, that's possible. But as long as we have two different solutions that are doing similar things with a little bit of overlap, that's never going to happen. This is a problem. So to solve that problem, OpenTracing and OpenCensus are merging together, and the new project is called OpenTelemetry. So it's the best of both worlds. It's not starting from scratch. Basically, we're taking lessons learned from both OpenTracing and OpenCensus, we're taking contributors and members from both of those communities, and we're forming OpenTelemetry so we can solve some of the pain points that I showed in the previous slide and come out with a single standard and a single solution that everyone can consume. This is beneficial for end users because they now know what dependency to take, and it's beneficial for vendors because they now know the standard that needs to be followed. They don't have to write their own or come up with side solutions. This is actually kind of unique in my opinion. If you look at CNCF, there's a lot of competing products, or even outside in open source communities in general. You don't typically see a merge like this, but I think this is extremely beneficial to the community. This is a case where if I have to instrument my app for a bunch of different languages, I don't want to have to mix and mingle and decide what to go choose. I want to have one standard. So I'm glad that we could come together and form a single solution here. All right, so OpenTelemetry overview. Going back to this slide. So what is OpenTelemetry trying to solve? All of it, the whole thing. We want to be able to supply traces and metrics and logs. We want to give you the API and the end-to-end implementation. We want to handle the wire format, all of it. Because if that's done and it's done well, then all you need is the analytics backend, and you'll be able to point to that or reconfigure to that without changing your code. It'll save software developers a ton of time. It'll make it possible to solve availability and performance issues with ease. So let's walk through each of these. Instrumentation APIs. What's going to happen? Well, the goal is to standardize around context propagation, but give you choice. So if you want to use a certain context propagation format, you can. The standard here is going to be W3C trace context. The first version should be coming out later this year. It's already in its final release. And OpenCensus as well as OpenTelemetry will have native support for W3C. It's likely to be the standard that you see going forward for trace context propagation, but it will support others as well. So if you're using Zipkin's B3, it'll support that as well. So it'll be easy for you to configure the context propagation format that you care about. While the initial focus will be around tracing and metrics, the goal is to enhance this to logs as well. If you look at the OpenCensus project, it already started to tackle some of the logs, at least in the Java client library. So what it provides today is the ability of adding trace ID, span ID, sampled information as tags to your log message. And why that's powerful is because now your logs will have context and correlation. I can say for this given trace and all of the calls that it made, show me all the logs. Or from a given log, show me the entire trace for that log. That's very powerful because one of the problems with metrics and logs is that in distributed microservices-based architectures, they're missing context and correlation. They are symptoms, they are signals, they are not root cause, they cannot provide problem isolation like they could in the monolithic world. So with distributed tracing as the foundation, you can actually enrich metrics and logs and make them more powerful. And so basically what will happen here is OpenTelemetry will provide a tracing and a metrics API, and then it will provide a client library implementation that you can leverage. And then depending on what you're leveraging from an application or an RPC perspective, it'll go ahead and hook up and integrate in there for you automatically. The net result is you just take a dependency and it should just work. And if you're using a framework or library that's already instrumented, if you have a service mesh like Istio, you can take advantage of that as well. From an implementation standpoint, the goal is to provide one reference implementation for every language. The first version of OpenTelemetry, which will be coming out later this year, I'll talk about that in a minute, will focus on 5 primary languages. I'll try to get them right. Go, Node, PHP, Go, Node, Python, Java, and .NET. There we go. Second time and I got it. But all the libraries will be supported going forward. SIGs or special interest groups are firing up right now if you're interested in contributing to them. In fact, I think I just saw one for C++ and C# that's just getting started. So if you're interested in another language, please get involved. I mentioned the W3C trace context propagation, and the goal is to have a wire format for tracing metrics and logs. From a tracing perspective, OpenCensus already has a wire format. OpenTelemetry will have one as well based on the best practices that we've learned so far. Data infrastructure, data collection, if you will. So OpenCensus had something known as the OpenCensus service. I mentioned that. It had an agent and a collector. OpenTelemetry will have a similar piece of functionality that you can leverage if you want. The goal is that it will support all popular open source software automatically. So for example, for tracing, that's Zipkin and Jaeger. From a metrics perspective, that would be Prometheus and StatsD. So that'll just work out of the box, but it's a pluggable architecture. So commercial vendors can also provide what we call receivers and exporters into that architecture, and you can take advantage of that as well. Many of them are already available. You can, of course, write your own if you have your own custom implementation as well. The goal is to support both tracing and metrics to start, but logging will come. So there's questions about like FluentD and what does that mean? We'll get there. We're not there yet, but those questions will be answered. And then the agent and the collector provide a ton of additional benefits and feature functionality. One of the questions earlier at the Jaeger session was, I don't want to use an agent. Well, the agent's actually very powerful. From a client instrumentation perspective, I can now point to localhost, which means I don't have to reconfigure my application ever. Localhost is always there. So I can deploy this application anywhere, and I'll know that it gets to the agent. In addition, the agent provides buffering and retry capabilities and batching capabilities. Those are things you'd have to add to your client libraries in every language that you're running in otherwise. That's overhead for your applications. You probably don't want overhead for your application. So ideally, you defer that to the agent, let the agent handle it locally, and then it can send to a collector. The collector can be used for sending this over a WAN. So if you have latency or high throughput of traffic, so you need to buffer or cache more of that data. The collector also offers advanced functionality like tail-based sampling. Sampling is very common in the distributed tracing world, but to date it's been mostly head-based, at least from an open source perspective. The OpenCensus service was the first open source software to have tail-based sampling open sourced and available. Typically you'd have to get that from a proprietary vendor. OpenTelemetry will offer tail-based sampling as well if you're interested in that functionality. OpenTelemetry goals. So let's talk about the elephant in the room, because this is kind of important. I mentioned OpenTracing, I mentioned OpenCensus, I mentioned OpenTelemetry. I said we were going to add the 2, 1 plus 1, and we're going to end up with not 2 but 1. Well, this kind of sums it up perfectly. The fear is we just invented another standard called OpenTelemetry, and now you'll have 3 choices. No, that's not the goal. One of our goals is to prevent this from happening. So how are we going to prevent this from happening? And the answer is we're going to provide backwards compatibility, and we're going to sunset OpenTracing and OpenCensus. What does sunset mean? Those repositories are going to go read-only by the end of the year. That's the plan. So we're basically working right now to make the first version of OpenTelemetry that'll be available later this year. Right now we're targeting September for the 5 major languages that I already mentioned. And then by the end of the year, by hopefully KubeCon North America, we will announce the sunset or the made read-only version of OpenTracing and OpenCensus. But what we're going to do is provide a bridge that has full backwards compatibility. So if you're on OpenTracing or OpenCensus, you don't have to do anything by the end of the year. It will still work with OpenTelemetry. You have nothing to worry about. And we will support backwards compatibility for at least 2 years. That's the end of 2021. So you have plenty of time to migrate over to OpenTelemetry as it becomes available. So our goal is to provide enough runway for people, but at the same time put some pretty firm dates in so we don't end up with 3 standards. We really want to consolidate. We want OpenTelemetry to be the future. We want there to be 1 API and 1 implementation. There's actually a Medium post on this that has more details if you're interested in more specifics. So 1 project, not 2, definitely not 3. The goal is to attack tracing and metrics, API and implementation for 5 major languages in the first release. The goal is to make it loosely coupled so you can take what you want. You don't want to use an agent or collector, that's fine. You already have your own client instrumentation, that's fine. You want to use a different API implementation than we have, that's fine. That's the wrong presentation. That's not fine, that's not fine. Here we go. So it'll be loosely coupled, and you can only take the pieces that you care about And then probably most importantly, there's open governance. In fact, we're following kind of the Kubernetes model here. So there'll be representation for many orgs, and there'll be fixed timelines on how long someone can serve on the governance board. So the project isn't pulled in any one particular direction. Again, there's a blog post on this on Medium as well. So governance. I just want to talk about this really quickly. There are special interest groups or SIGs that are getting started right now. So now is a great time to get involved if you're interested in contributing to this. There are GitHub issues open on Open-Telemetry on GitHub. That is a gotcha. It's not OpenTelemetry, it's Open-Telemetry on GitHub. Otherwise you won't find it. Sorry about that. Someone has OpenTelemetry. We're trying to fix that. So there's special interest group for each of the languages, and then there's different community membership things. You can become a member, an approver, or a maintainer. There are certain requirements in order to get approved for that. You have to have a certain number of contributions, and you have to be active in the community, and you have to be recommended by someone that's already part of the community. If you're interested in learning more, if you go to open-telemetry/community, that's where the repository is with all of these details. And then finally, we're using the CNCF Code of Conduct. OpenTelemetry is a CNCF project. The goal is to represent as many different companies and organizations as possible. We don't want to have unequal representation or one company kind of driving the project. We really want the community as a whole to drive the project. Right now, elections are based on the Kubernetes model, so there'll be 9 seats with limits on overrepresentation, so no company kind of controls the governance board. Only active code contributors get to vote, kind of important. And there are maximum term limits, so again, the idea is to rotate people and companies in and out of the project. All right, so next up I want to talk about backwards compatibility. So if you're coming from OpenTracing or you're coming from OpenCensus, what does it mean? Let's start with OpenTracing. So OpenTracing has a few changes to the API itself. Apologies in advance, these slides for OpenTracing are a little technically deep. So I'm going to summarize them for you, and then you can review them if you care about the specifics. So the 3 major changes for OpenTracing are around sampling. So there'll be formal definitions on how sampling is handled. Terminology changes. So for example, in OpenTracing, metadata was known as tags, but in OpenTelemetry, that'll be called attributes. So there'll be some naming changes to get used to. And then the trace ID, span ID type changes to make them more standard for the W3C, how the context correlation's handled with given the W3C trace context that's coming out. That'll formally make some changes to the OpenTracing API spec. But again, it will be backwards compatible. You don't necessarily need to worry about this. As you move to OpenTelemetry, these are just things to be aware of. As I mentioned, there's some naming changes, so tags or attributes, logs become known as events. These slides are attached to the session on the scheduler builder, so it should be easy to get them if you're interested. And all the other notions like follows from and linked spans will all be included, so you'll have feature parity with what you're used to from an OpenTracing perspective. The tracer itself will also have some changes. So for example, instead of ending a trace, that terminology, that function call will be removed. Hopefully you'll see it in a second. Instead, it will probably support flushing. You see the word probably. We're still defining the new API and specification. That's actively going on right now. But consensus right now is that trace.close will probably go away, and trace.flush will probably be introduced instead. Again, you can get involved in the community and you can follow this live if you're interested in the specifics for OpenTracing. For OpenCensus, the story's a little bit easier. The primary change is that there will be a clear separation between the API and the implementation. That's really what was missing in OpenCensus. So the idea here is you'll be able to replace the API with another one if you want to. So if there's some other implementation or some other API specification you want to follow, you can. Previously, that was not possible. It was tightly coupled with the actual implementation itself. So dividing that and clearly separating the two provides more choice for end users. That's a lot more flexible model and basically what the inherent ask is. Other than that, the instrumentation API is going to change a little bit, but none of the specifics are going to really impact you. I do want to kind of walk through what a migration might look like from OpenCensus because it's kind of interesting visually. So today, let's say that you have a service or an application written in whatever language, let's use Go, and you go ahead and you leverage the OpenCensus client library. It actually has an API and an implementation. I said that they're tightly coupled. That's how OpenCensus is today. So once OpenTelemetry, the first version, comes out, what you would basically do is you would take a dependency on the API and the implementation, but that will happen automatically. You'll just basically upgrade OpenCensus. So what OpenCensus is going to do very soon is they're going to do a cutover. So when you upgrade to the latest version, you'll still get the OpenCensus API, but the OpenCensus API will just go and call the OpenTelemetry API, and the OpenTelemetry API will call the OpenTelemetry implementation. It'll be transparent to you. You won't make any change other than upgrading your OpenCensus version. Then you will eventually take a dependency on the OpenTelemetry library itself. So that's a code change that you make. That gives you a clear separation between using OpenCensus and OpenTelemetry and provides a bridge as you make this migration over. And then finally, you would remove your dependency on the OpenCensus library once you're ready to do the full cutover. So you can make it a four-step process. You can make it a one-step process. Again, the goal is to provide choice and flexibility on your migration path. But given this flexibility, it should be very easy and very non-destructive when OpenTelemetry is available. And now let's talk about the OpenCensus service. So I mentioned that's made up of an agent and a collector. If you're not too familiar with the architecture, there's a notion of receivers, how you get data into the OpenCensus service, and exporters, how you get data out of the OpenCensus service. And all the popular open source solutions are supported. So for tracing, that's Jaeger and Zipkin. For metrics, that's Prometheus and StatsD. There's also an OpenCensus endpoint as well. And then commercial vendors have provided their own exporters traditionally. They don't typically provide receivers today that are available. So what's going to basically happen is we've already ported the OpenCensus service to the OpenTelemetry service. So very soon we will cut a new release, and you'll basically just deploy that release. It'll look exactly the same. It's basically just a rename. And then over time, we are going to release the OpenTelemetry receiver and exporter, the new data format that merges the best of both worlds. Over time, you will then migrate to that OpenTelemetry service. Once you have fully migrated over, then eventually in 2 years, when backwards compatibility gets removed, we will remove OpenCensus as a receiver, as it will no longer be necessary. So again, the transition should be pretty smooth and seamless for you, especially from the service perspective, given that OpenTracing didn't have a service today. This is basically a port over from the OpenCensus service itself. With that said, there are some architectural changes that are being made. They'll be transparent to you, but the agent and collector code bases are based on the same code, but they're not identical. We're moving to an identical binary for both with just different configuration options. And we are looking to overhaul the configuration that was used in OpenCensus service. So in OpenTelemetry, there'll be a new standard way of defining it that's much more scalable and enterprise ready. So that should be available here probably in the next month. Very soon we'll be cutting the next release of this. You can follow the OpenTelemetry service to get more details. Okay, so let's summarize because I threw a lot of words at you. What's next? The first version of OpenTelemetry is expected by the end of this year. We'll have support for 5 languages. I'll try again. Go, Node, Python, Java, .NET. Hey, first try. Nice. There will be a bridge between OpenTelemetry and OpenTracing and OpenCensus. So if you're using OpenTracing and OpenCensus, keep using it. It will work. It will be okay. In fact, if you plan on instrumenting today, like in a greenfield environment, you have to use OpenTracing or OpenCensus. OpenTelemetry is not ready yet. It will be ready. We're working on it, but it's not ready yet. So if you need instrumentation today, go look at OpenTracing and OpenCensus. We try to mark that in the repositories. So if, for example, if you go to the OpenTelemetry service, it clearly says, please go use the OpenCensus service. So we're trying to make it clear to the community what's going on, but at the same time be transparent as new features are available. The goal is to sunset. That means read only. So going forward, there will be no changes to the OpenTracing or the OpenCensus GitHub repository by the end of the year. That's the current target. Those repositories will remain in read-only mode for at least 2 years with backwards compatibility. That backwards compatibility should last through 2021. Of course, if dates slip here, then we'll give you specific dates. But right now, these are our targets. And then OpenTracing has some changes to the terminology, the context propagation, and sampling, as I already mentioned. And OpenCensus will have a clear separation from the API and the implementation. Those are probably the key takeaways here from the differences as well as the compatibility and the merging between them. Now, of course, we'd love to have you be involved in this community. Now's a great time to get involved, right? So if you're interested in a particular language, if you have feedback on direction, if you want to contribute to the website or the documentation, we'd love to have that as well. The OpenTelemetry community is very active right now. There is a debate on whether we're going to be on Gitter or Slack. Right now we're on both, but you can come find us in one of those two forums and definitely post your questions there, or of course you can open GitHub issues as well. All of the SIGs are documented on the OpenTelemetry community page. They have weekly or bi-weekly meetings with meeting links in there, and you're definitely welcome to join. If it's not in a friendly time zone, please open a GitHub issue, right? We want to make sure that the community can be involved. And if that means having every other meeting being in a different time zone, we are definitely open to that. So the more feedback you provide, the better that we can make the community for everyone. And with that, I'd like to open it up to some questions. When is FluentD coming? Nice. I think there's actually a GitHub issue open for this. So again, so when is FluentD coming is the question. The initial focus is traces and metrics. So for the end of this year, I wouldn't expect to see any logs. It's possible if we are able to consolidate and get everything done quickly, we'll get it by the end of the year. But I suspect, when is it coming? I would guess next year. That would be my hypothesis. What you may see is the ability of adding trace ID, span ID, sampling ID, like you saw in OpenCensus. That might come early, but any native integration with FluentD or what that looks like, today, our guidance would be just continue using FluentD like you have been, and you can enhance the log messages if you want inside of your application using OpenTelemetry. Long term, we can see if there will be changes to things like FluentD. That was probably going to be, maybe KubeCon North America, I'll have a better answer as to timelines. This is towards the end of the year. But right now, that isn't the highest priority. The highest priority is really sunsetting OpenCensus and OpenTracing. Yeah?
Can you talk a bit to OpenMetrics and how that relates to the OpenTelemetry project?
Yes. So the OpenMetrics project is primarily a data format project. So it's the format for sending metrics out over the wire. Initially, the thought was to keep that separate, but OpenCensus actually has a format for sending trace data. So we are actually in active talks with the OpenMetrics and Prometheus folks about this. The talks are still early, but there may be some ability to join efforts there as well. So that is likely to happen sooner than, say, logging, primarily because tracing and metrics are the top priority to start with. But there is some amount of overlap there. With that said, my understanding, which may be incorrect, is that OpenMetrics is still a little early. So we're just trying to make sure we're involved in the conversations and they understand the direction that we're going in as well to see if there are some synergies there and if we can help join. Other questions?
And OpenCensus. OpenTracing and OpenCensus, they provide a capability to configure the application from the environment itself, right? So will OpenTelemetry have that kind of capabilities?
When you say from the environment itself, what do you mean?
So say I want to connect to a Jaeger collector for all the traces, right? So my application can read stuff from the environment, right? Which auto configures the applications to send it to the given collector. So
you're asking about like environmental variables and such. Yeah, okay. So yes, Jaeger supports environmental variables today. OpenCensus supports environmental variables today. The expectation is that OpenTelemetry will as well. In addition, the goal is to provide more integrations. So for example, OpenCensus in the ecosystem repository actually supported a webhook admission controller to Kubernetes, where it could actually tag in via environmental variables pod information. So for a given application, I could figure out what pod it was running on when it generated that trace. What we're looking to do is to provide even better native hooks. Like, wouldn't it be ideal if the agent could just tag that on and I didn't have to modify the app pod? So another reason to potentially consider the agent is that it will actually collect host metrics from, say, Kubernetes natively, instead of you having to like get drop wizard only from your app and not being able to get down to the host itself. The agent can get down to the host level. So yes, the goal will be to support environmental variables and ideally provide as much native integration as possible. So again, you have flexibility and choice. You can turn off and turn on what you care about.
So this is more of a terminology question. So what is your definition of the difference between telemetry and observability?
Good question. So observability is a common term that came out in the cloud native era, or as you move to more microservices. The way I like to think of it is observability, the term observability came around because monitoring was, in the previous generation with monolithic applications, it was known as monitoring, and the problem space was different. You could use just metrics and logs, and you knew where the problem was. It was in the monolith. But as you move to a distributed-based architecture, that's not the case anymore. And as errors propagate upstream and downstream from a call, traditional monitoring doesn't work. The term observability kind of came out of that. Telemetry, on the other hand, that's more of a loaded term. I think we went back and forth on naming for the project, given that OpenTracing was taken, OpenObservability wasn't an option. OpenCensus was, the goal wasn't to use OpenTracing or OpenCensus because we didn't want to cause confusion in the community. We wanted a new name. So telemetry kind of came out of that. Telemetry data in general is just signals, you can think of it as, from your application, which is very similar to observability. Observability, you typically think of the 3 pillars of observability. So you just think traces, metrics, and logs. But as I mentioned, we're also trying to attack different verticals, API, implementation, wire formats. So telemetry is more encompassing in a way, and so we felt that better represented the name of the project, because the goal is not just to provide signals. We want to get you to root cause, context, and correlation through those signals. I hope that answers your question. You have a question?
Is there any plan to support OS like Linux, Google OS for OpenTelemetry?
Yeah, so the binaries support Linux distributions. They did support, at least the OpenCensus service did support Windows. I think we dropped support for that, but we can get it re-added. But yeah, from a language perspective, it's supported. From a cloud perspective, OpenCensus was supported by Google Cloud Platform and Microsoft Azure. AWS has their own solution, and we're also talking to other cloud providers as well. What we're hoping is that overall cloud providers will standardize on OpenTelemetry as well, because then I could answer the question of, is it my app or is it my cloud provider that's causing the problem? Today you can't do that, and so if you rely on a platform service from a cloud provider, you can't easily tell whether it's slow or not, and that results in support calls. So we're working with other cloud providers to try to get them on board with the OpenTelemetry project.
Thank you.
I have 1 more minute. Any more questions? 1 more in the back.
Do you also care about long-term storage of the data, or is that out of scope for the project?
Yeah, so basically after it gets to the collector, today it's out of scope. Provide your backend of choice. So whether that's a local backend like Jaeger, or an open source backend like Jaeger, or to a commercial vendor like Omnition, or Google Stackdriver, or whatever you're going to use, that's kind of outside scope. With that said, while it's in the agent and the collector, there's some amount of persistence that's needed there. Typically today that's done in memory, which means it's a little lossy if you have to restart. There are actually tickets open to add like a dispatch queue for that, so that you can actually retry that data should you, for whatever reason, lose that node, or if you want to have longer term persistence. What we typically see is it's not entirely the end of the world if you lose a trace or a metric, as long as you get most of them. So having it be in memory is typically sufficient. But then the back-end storage of that's outside scope. Features to get it to the back-end, though, are not. So for example, the OpenCensus service supports, as I mentioned, tail-based sampling. That's a way of reducing the amount of data that I send to a back-end and hopefully increase the amount of valuable data, like error traces that I send to it, versus the number of non-error traces that I send to it. But actually storing it and persisting it, that's typically considered a back-end problem outside the scope of OpenCensus. All right, that's all the time that I have. I'll be here for a couple minutes afterwards, though, if there are additional questions. Thank you so much for joining.